In the first example from this lesson, we solved a system using row echelon form or Gaussian elimination. And what we can do with a matrix is put its elements in row echelon form. And the rows would have 1 as their leading coefficient, you can think of it. And if there is a bottom row of zeros, that's okay. But all of my leading terms have to have 1. So in this last example in this video, we're just determining whether the matrix is in row echelon form. Right away, I can see that A is not, because this should have been at the bottom. B is in row echelon form. Notice how the ones are making a triangle. C is most assuredly not in row echelon form. And I would have to do some real math to get it there. I can't just move them around like I could in choice A, or part A, excuse me. In this example, we're given a table displaying some data about Manuel's trip to Italy. And what we're trying to find is how many days he spent in each city. So first thing I'm going to do is arrange this data in a matrix. Next thing I'll do is make these numbers smaller. Notice that each row has a greatest common factor. So we're going to divide all the rows by their greatest common factor. So we're going to take A and divide it by 60, B and divide it by 10, C divided by 5. And when I do, I get 1, 2, 1, 12, 4, 9, 3, 49, and 3, 2, 4, 26. So my first row already looks good. I'm going to use it to eliminate the 4 and 3 in rows B and C respectively. So I'll be leaving the first row alone. But taking that first row and multiplying it by -4, whoops, clean that up a little, and adding it to the second row to get my new second row, and then I'll take -3 times my first row and add it to the third row to get my new third row. Calculator. -4 times 1 is -4 plus 4 is 0. -4 times 2 is -8. -8 plus 9 is 1. So that works out nicely. -4 times 1 is -4. Times 3 is -1. And -4 times 12 is -48. Plus 49 is 1. In the third row, -3 times 1 is -3. -3 plus 3 is 0. -3 times 2 is -6. -6 plus 2 is -4. -3 times 1 is -3. Plus 4 is 1. -3 times 12 is -36. Plus 26 is -10. So my leading coefficients in rows A and B look good. Now I've got to get rid of the -4 in row C. So what I will do there is multiply the second row by 4 and add it to the third row. So I'm leaving rows A and B alone. and multiplying row B by 4 and adding it to row C. So 4 times 0 is 0, 0 plus 0 is 0. 4 times 1 is 4, 4 plus negative 4 is 0. 4 times negative 1 is negative 4, plus 1 is negative 3. And 4 times 1 is 4, 4 plus negative 10 is negative 6. Next, my last row I can divide by negative 3. So I'll leave my first and second rows alone again. But take my third row and divide it by negative 3 to get 0, 0, 1, and then 2. So now I'm able to see that my z value is 2. So y minus 1 times 2 is 1. That means y minus 2 is 1. So y is 3. Oops. In my first equation, in order to solve for x, I have x plus 2 times 3 plus 2 equals 12. So that's x plus 6 plus 2. So that's x plus 8 is 12. So x is 4. And in the context of this problem, my values of the variable are 4, 3, 2, in that order. So that means he spent 4 days in Venice, 3 days in Rome, and 2 days in Naples. We can take this process of cleaning up the matrices further and write the matrices in what we call reduced row echelon form. And so those leading coefficients would still be 1, but everything else on the left side of the bar would be zeros. So let's do an example like that. First, we write the system as a matrix. And I've already got my leading coefficient of 1 in my first equation, so we'll go ahead and get rid of the negative 3 and 2 in the next step. So I'll leave my first equation alone for now. But take that first equation and multiply it by 3 and add it to my second equation to get my new second equation, or second row. Take negative 2 times that first equation and add it to row C to get my new row C. So here we go. 3 times 1 is 3. 3 plus negative 3 is 0. 3 times 2 is 6. 6 plus negative 7 is negative 1. That worked out nicely. 3 times negative 3 is negative 9. Negative 9 plus 9 is 0. And then 3 times 7 is 21, plus negative 12 is 9. In the next row, I take 2 times, negative 2, times 1, I get negative 2 plus 2 is 0. Negative 2 times 2 is negative 4, plus 1 is negative 3. Negative 2 times negative 3 is 6. 6 plus negative 5 is 1. Negative 2 times 7 is negative 14. Negative 14 plus 8 is negative 6. In my next step, once again, in order to conserve your paper, I'm going to do 2 steps at once. I'm going to be leaving the second row alone, but I'll be using it to make this a 0 and this a 0. So in order to do that, I will be multiplying row B by 2 and adding it to A to get my new A row. I'm going to leave row B alone, but I will multiply it by -3 and add it to C to get my new C row. So we're leaving this alone for now. So 2 times 0 is 0, 0 plus 1 is 1. 2 times -1 is 2, -2, excuse me, plus 2 is 0. 2 times 0 is 0, 0 plus -3 is -3. 2 times 9 is 18, 18 plus 7 is 25. For my third row, I'm multiplying 0 by -3. I get 0, 0 plus 0 is 0. -1 times -3 is +3. 3 plus -3 is 0. -3 times 0 is 0. 0 plus 1 is 1. -3 times 9 is -27. Plus -6 is -33. So my third row is great, my second row is almost great, and my first row is one step away from being great. So in my next step, I'm going to change the sign of the second row and multiply the third row by 3 in order to add it to row A. So 3C plus A and -B, and I'm going to leave C alone. Three times 0 is 0. 0 plus 1 is 1. 3 times 0 is 0. 0 plus 0 is 0. 3 times 1 is 3. 3 plus -3 is 0. 3 times -33 is -99. -99 plus 25 is -74. And then I'm just changing the signs in this row. 0, 1, 0, -9. And my solutions are all right here staring at me. My answer is -74, -9, -33. As I look at this matrix, I hope you don't mind if before I write my first matrix, I'm going to switch those two rows around so that I'm starting with -1, -2, -4, -1, and 4, 9, 16, 2, 2, 4, 9, -5. Just means I'm starting closer to the finish line. So, first step I'm going to do is use that first row to get rid of the 4 and the 2 in the second and third rows. So I'm going to leave the first row alone. But multiply it by 4 and add it to my second row. Multiply it by 2 and add it to my third row. So 4 times -1 is -4 plus 4 is 0. 4 times -2 is -8 plus 9 is 1. 4 times -4 is -16. -16 plus +16 is 0. That is fantastically convenient. 4 times -1 is -4 plus 2 is -2. In the next row, 2 times -1 is -2 plus 2 is 0. 2 times -2 is -4 plus 4 is 0. That is awesome. 2 times -4 is -8 plus 9 is 1. This is beautiful. 2 times -1 is -2 plus -5 is -7. So how awesome is that? I got 2 of my rows done already. Now I just need to use them in order to clean up row 1. And that I really don't feel comfortable doing in more than just one step at a time. So I'm going to first multiply the second equation by 2 and add it to row A. So I'll be leaving rows 2 and 3 alone. And 2 times 0 is 0. 0 plus -1 is -1. 2 times 1 is 2. 2 plus -2 is 0. 2 times 0 is 0. 0 plus -4 is still -4. 2 times -2 is -4. Plus -1 is -5. Then I'm going to multiply the third row by 4 and add it to A. So, what did I just say? I said 4. Again, leaving rows B and C alone. So 4 times 1 is 4. 4 plus, let me start from the top, sorry. 4 times 0 is 0. 0 plus -1 is -1. 4 times 0 is 0. 0 plus 0 is 0. 4 times 1 is 4. Plus -4 is 0. 4 plus -7 is -28. -28 plus -5 is -33. And now the last thing I'll do is just change the signs of row A. So -A, I'll have 1, 0, 0, 33, and everything else is beautiful, and my solution is right there staring at me. It is 33, -2, -7. In algebra, you may recall that sometimes a system of equations had infinite solutions and sometimes it had no solution. So let's take a look at what that looks like when we're solving the system using matrices. First thing we're going to do is put these in a matrix. And this time I didn't luck out and get one of my equations in having a leading coefficient of 1, so I've got to figure out how to get that first. What I would like you to notice is if I take my first equation minus, I'm sorry, let me say that again. If I take my second equation minus my first one, then my leading coefficient of the resulting equation would have a coefficient of 1. So that's what I'm going to do in my first step, is take B minus A in order to rewrite my first equation. I'm going to leave the other ones alone for now. So 1, because 4 minus 3 is 1. 2 minus -1 is 3. -3 minus -5 is 2. And 6 minus 9 is -3. 4, 2, -3, and 6, -7, -11, -3, and 3. And now I'm ready to eliminate the 4 and the -7 from the second and third rows. I will do that by multiplying the first equation by -4 and adding it to row B. And multiplying the first equation by 7 and adding it to C. So I'm leaving the first row alone. 1, 3, 2, -3. 1 times negative 4 is negative 4. Negative 4 plus 4 is 0. Negative 4 times 3 is negative 12. Negative 12 plus 2 is negative 10. Negative 4 times 2 is negative 8. Negative 8 and negative 3 is negative 11. Negative 4 times negative 3 is 12. Plus 6 is 18. In row C, 7 times 1 is 7. 7 plus negative 7 is 0. 7 times 3 is 21. 21 plus negative 10 is, 21 plus negative 11 is 10. Talking ahead of myself. 7 times 2 is 14. 14 plus negative 3 is 11. 7 times negative 3 is negative 21 plus 3 is negative 18. And if you notice, rows B and C are exact opposites of each other, which means if I go through and add those two equations together, then I would have a row of zeros. So let me show you what I mean by that. I'm going to leave the first row alone. 1, 3, 2, negative 3. And then when I take, I'm going to change the signs of my second row. But in my third row, I'm just going to have the result of rows B plus C added together. And so because my last row is just a bunch of zeros, what that translates to as an equation is that 0 equals 0. And that is true. Another thing that I want you to notice is that now we have more equations than we do variables. And whenever that happens, right away you know that there's infinite solutions. And when there are infinite solutions, we express the solution as a point where the 3 coordinates, in this instance there's 3 coordinates, we express them all in terms of the last coordinate. And so in this case that's z. So we're going to solve for y in terms of z. And once I have that, then I'm going to use it in order to solve for x in terms of z. So here's what I mean by that. I'm going to take this equation and solve for y in terms of z. So 10y would equal negative 11z minus 18. And when I divide both sides by 10, I get that y is negative 1.1z minus 1.8. And now that I know what y is in terms of z, I can figure out what x is. So I'm going to rewrite this equation, substituting in this for y, and then I will solve for x in terms of z. So that'll be x plus 3 times negative 1.1z minus 1.8 plus z, that's 2z, equals negative 3. Distribute the 3. I've got x minus 3.3z minus 5.4 plus 2z equals negative 3. I'm going to combine my z's and get x minus 1.3z. I will also add the 5.4 to the other side of the equation, so that'll be 2.4. And that means x is 1.3z plus 2.4. So my solution here is all the points in the form 1.3z plus 2.4, comma, as I'm writing a coordinate, negative 1.1z minus 1.8, comma z. In my next system, I kind of lucked out a little bit in that there's a equation with a leading coefficient of 1. And I hope you don't mind. I'm going to try to save a little paper again. I'm going to take the first equation and multiply it by -4 and add it to the second equation. I'm going to multiply the first equation by -8 and add it to the third one when I write my first matrix. So my first line is 1, 3, 4, 8. -4 times 1 is -4. -4 plus 4 is 0. -4 times 3 is -12. -12 plus -2 is -14. -4 times 4 is -16. -16 plus -1 is -17. And -4 times 8 is -32, plus 6 is -26. -8 times 1 is -8. -8 plus 8 is 0. -8 times 3 is -24. -24 and -18 is -42. -8 times 4 is -32. -32 and -19 is -51. -8 times 8 is -64. -64 and -2 is -66. From here, what I would hope that you'd notice is that if I multiply 14 times 3, I get 42. If I multiply 17 times 3, I get 51. So what I'm going to do is multiply the second equation by -3 and add it to the third so that things will cancel out for me. And I'm going to leave the first and second equations alone. So -3b plus c. -3 times 0 is 0, 0 plus 0 is 0. -3 times -14 is positive 42 plus -42 is 0. -3 times -17 is positive 51 plus -51 is 0. -3 times -26. Oh, I don't have my calculator handy. What is that? That's 18 and 1. That's 78. Positive 78 plus -66 is 12. So as it turns out, the actual number that I got there doesn't really matter. What matters is that it is a number that isn't 0. So what I mean by that is, look at that third line there. That third line translates to an equation, remember. And that equation would be saying that 0 equals 12. That's false. Therefore, there is no solution.